Thank you all for coming today. So I'd like for you to imagine what it would be like to live in a 3D printed world. Let's explore some of the paradoxes and promises inherent in additive manufacturing. With 3D printing, we'll begin to disrupt traditional top-down retail and empower customers with mass customization, and also empower economies with localizing manufacturing. 3D printing will bring massive societal and environmental impact. So how many of you in the room have ever used a 3D printer? Okay, cool. That's actually a pretty good number. So if you've used one, you probably haven't used a $500,000 machine or a $1,000 or $1 million machine. If you have, you probably had a better experience. But unfortunately, this is what a lot of people think about when they think about 3D printing. They're like, it's bad, you get bad prints, like this crazy one. You don't have many materials that you can print in, namely it's like plastic, PLA filament. And if you even have access to a 3D printer, it can break, and often it's a slow and cumbersome process. But this was the past, and this is the future. Already we can print in hundreds of materials, metals ranging from 14-karat gold to platinum to titanium, stainless steel. We can print in construction materials like nylon, plastic, cement, glass. You can also do bio printing, bio 3D printing, and print in human material, bone, cartilage, even stem cells, which is obviously a controversial one. So I'm going to cover a few trends and highlights in 3D printing, things that you might not be aware about that are really cool. Right now, we have polyjet printers that are allowing us to print in multiple materials at the same time. This allows for you to create really complex, interesting objects. And I think we've all heard of Invisalign by now. This is a great example of how 3D printing and 3D modeling are disrupting an industry like orthodontics. And with mass customization, we're giving customers a better product. Prosthetics, humans and animals alike are benefiting from 3D printed and custom fit orthotics and prosthetics. This is a dolphin at the Okinawa Chirami Aquarium. He has a 3D Fuji, is his name, and he has a 3D printed tail fin. And then also 3D printing is getting bigger. We have large scale production. Recently, tech visionary and Google executive Eric Schmidt said at the Milken conference, he talked about the top 6 trends, tech trends that he sees. And alongside self-driving cars and virtual reality, things we all know about, he cited 3D printing of buildings as being something that we should all be watching. So imagine if you walk past an empty block, and then a few days later you walk past and the whole building has been constructed in recycled materials. This is the future that Eric Schmidt sees. And on the flip side, we have nano printing, so micro printing. An example of this would be Jennifer Lewis at Harvard, her team at Harvard. They've already created a fully functioning battery that's the size of a grain of sand. So you can imagine the implications of this with things like medical devices, compact electronics, and micro robotics. And I touched on this earlier, but organic materials, this is really interesting. We're printing stem cells, we're creating knee replacements, but I think things that people don't realize are how soon we are to really incredible advances in medical technology. And pretty soon, knee replacements will come with medicine, like pain medication and antibiotics that are slowly released into your system. So recently, Stephen Hawking was quoted as saying that with creation of 3D printed organs, we'll, quote, make humans almost immortal. And I think this comes with tremendous questions around ethics and is obviously really exciting, but also something that has to be done carefully. So 3D printing. Today, over 50% of 3D printing is used for prototyping, which you can see here. But within 3 years, this shift will go from prototyping to production, so creating print-ready parts. And these are some examples, many German, of early adopters, but this is just the tip of the iceberg. We have Mercedes-Benz, they're already 3D printing parts for trucks. BMW recently invested in a metal 3D printing company. Deutsche Bahn and Siemens are 3D printing parts for trains. Singapore Airlines has partnered with Stratasys recently, and they're 3D printing parts for their airplanes. And then GE is really a visionary in this space. They've already spent over 1.5 billion on research in additive manufacturing. And a specific example of what they've done would be with their jet fuel nozzles. So that used to be a part that would take a long time to produce. It would be 20 separate parts that were welded together. Now it's just one piece. It's 20% lighter and 5 times stronger. So limitations of traditional manufacturing. Often it was something that was prohibitive for smaller manufacturers. There was high volume minimums, setup costs that were expensive, and it was location specific. And with global sourcing, air and shipping, this produced lots of waste, both time and money, and of course pollution. So all of these things, many are seen as the death of traditional manufacturing. And alongside visionaries like Eric Schmidt, Stephen Hawking, and GE, we have Shapeways, the Shapeways co-founder and CEO, who recently said that 3D printing, the future of 3D printing, will usher in the next industrial revolution. And so we see the analog of mass production starting to shift towards a direct digital manufacturing. So this is an example too. You can think about Stratasys. They have this new continuous build unit where we're starting to see the shift towards away from physical inventory and a focus on virtual inventory, so creating products on demand. And kind of what I see personally as a founder, there's been kind of this gap in creating access to the 3D printers, but not having access to education around using 3D printers and mechanical engineering software. And so I know what I'm very passionate about personally is educating Gen Z. Especially initially, I was very focused on Gen Z girls, giving them access to engineering software, empowering them to learn. So my product, KiraKira, we have a website where we teach girls and boys about engineering and mechanical engineering through building products that they love. So they'll learn how to make iPhone cases or skateboards, and in the process, they'll learn transferable skills in engineering. One of our partners is Autodesk, and this is another example of a really cool project that they're doing called Superhero Cyborgs, and they work with kids that need prosthetic limbs, and they help the kids to design their own imaginations. They create these incredible prosthetic limbs that do things like shoot confetti, and they learn incredible skills in engineering in the process. So there are lots of companies that see that this is a focus that we need to be educating the next generation. So my app, KiraKira 3D, you can download it. It's only Apple, iOS right now. But we want to make this access even easier. So we want for kids to be able to design on their phones, make models quickly, and 3D print them with the click of a button. And basically our ultimate vision is to see the next generation of consumers become creators with the first 3D modeling mobile experience. So I hope you can enjoy it. Design, 3D print, buy and share. And thank you for listening, and I'd love to answer any questions that you have.
Are there any questions in the audience? Just raise a hand, then you will get such a cube to ask your question.
I'm really excited because one of my friends from Virginia is in the audience today.
You want to ask a question?
Oh.
So, not a microphone?
It works. Just try again.
Thank you so much for coming today and for sharing. I mean, I've seen KiraKira start, and it's so nice to see where it is now. It's grown tremendously from a jewelry, I guess, enterprise to a more education-focused one, which is fascinating. My question is, if you could wave a wand, where do you want to see the gender mix-up in this male-dominated industry in 30, 40 years?
I mean, obviously 50-50. I would like to see that in, hopefully within 20 years, that this is something that is societal. I mean, not all countries have the crazy gender discrepancy that the United States and I think Germany is sort of similar. But for us, the STEM drop-off happens when girls are in middle school in 5th grade, they're on par with boys. About 80% are interested and proficient in math and science. And then something happens in middle school, and that number drops to 20%. So yeah, I would love to see it be 50-50, and I think that's something we're really passionate about with our product, is seeing that balance.
Cool.
Thank you.
Yeah. Somebody else has a question? Just really back in the back,
Yep.
last row.
Yay.
Could you
Can you
maybe
throw it all?
throw it in the middle and
You?
getting for who is
It's
catching it? Just in the middle, maybe.
You can do
one
it,
with the blue
Greg.
shirt. Oh, it's the longest distance I've seen so far.
Speak into this.
Yeah, just hold it closer to you.
Right, one quick question, like when is Android coming?
So we're building it right now, probably 3 to 4 months.
Okay, no problem. And in the same theme,
Are you an Android developer?
no, I'm a mechanical engineer.
Oh, cool. Very cool.
So-
Okay.
Yeah, I had this conversation with a friend of mine just like yesterday about like getting more women into science and engineering because it's actually a very creative field. You need people that can think creatively, but unfortunately, it just drops off, right?
Yeah. Yeah.
So, okay, so I can see the implications for this, like just what you can design with this in terms of fashion and art, but they're still going to need the skills in terms of engineering and how the software works. So how are you going to like bridge them?
Yeah, so for us, that's really where we have the app, which is kind of like a first touch, the first experience that they have to get them excited, to get them, understanding more about STLs, creating 3D models and 3D printing. But we're really passionate too about our website and having educational content that actually teaches very technical skills we have classes that teach SolidWorks, Maya, starting with Tinkercad and going all the way up to something like SolidWorks.
So how early do you introduce like little girls to these sort of softwares?
We just opened our first physical retail location in Ghirardelli Square in San Francisco, and we're offering summer camps where kids can come in and start learning. And we have girls as young as 4th grade, 5th grade, and they're using Tinkercad. But we see they get really excited about learning Tinkercad, and then they kind of graduate from Tinkercad to Fusion 360 as soon as they get that spark of I want to make this thing and I can't do it in Tinkercad, then they're motivated to actually learn a harder program like Fusion 360. So I think it's that physical object at the end that really creates that incentive and motivation and is a real world tangible reason why girls, I think, often are really good problem solvers, and there needs to be a reason why they're learning this. And so I think having the product, the 3D printed product, is very important.
Very cool. Thank you.
Yeah, thanks.
Thank you, Suz, very much for your inspiring speech.
Oh, thank you.
A big applause.